And finally, long last, we've got the algebra review that takes place at the end of this chapter, solving simultaneous equations. Actually something I do for fun in my spare time. Not even kidding, not even kidding. Okay, so, but let me give you kind of an overall view of how that works for those of you who aren't familiar with it. There are three ways that I kind of view solving those sorts of problems. But first of all, let's even talk about what they mean. To solve simultaneous equations means that you have two equations that you need to satisfy at the same time. That means there's going to be a solution in this case because all of the problems in this section are linear. Now, what does that mean? What does linear mean? Okay, so let's take number one for the easiest example. You're given that x equals y and that 2x equals y plus 8. Okay, now I know instantly by looking at these that their picture, when I draw them out, they're just going to look like lines. And the way I know that is because there's no x squared component. There's nothing more complex than a single variable, or sorry, not a single variable, just a simple, this one's x to the first, this one's y to the first. Okay, so that means that they have to look like lines. Okay, so let's go ahead and graph them. Seems like a good enough way to do it. And the most basic way to graph, I think, is to just pick a few points. X and x equals y, that's going to be pretty easy. Pairs are going to look like if x is 0, y is 0. If x is 1, y is 1. Yada, 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 and so on and so forth. Okay, so let's focus, well, we could go negative also a little bit, so I'll allow a little bit of room. What I'm drawing here is a Cartesian plane. Oh, I definitely didn't need that. Oh, well, whatever. And the coordinates, the x coordinates are going to go along this line, the horizontal axis, and the y coordinates are going to go along this line. We can do it 1, 2, 3, 4, 5. We'll just do it 1 to 1. 6, 7, 8, 9, 10. 2, 3, 4, 5. 6, 7, 8, 9, 10. I'll extend that one up a little bit. And then negative, this would be the negative x coordinates, and these would be the negative y coordinates. 1, 2, 3, 4, 5. So this will be negative 5, negative 10, and this one only goes as far back as negative 3, which is fine, just to give us an idea of where the line goes. Okay, so the first one, x equals y, totally easy to graph. Let's pick the points on it. 0, 0, 1, 1, 2, 2. So for this one, 2, 2, you'd go over 2 and up 2. And eventually, I should get a straight edge. Having trouble. Here we go. So it's going to be all these points. Now, as you know, I only needed 2 points because we all know that 2 points determine a line. However, I did a few more. I just plotted 3, and that matches up pretty well. So anywhere you go out some number and go up the same number, those points, every single one of those points is going to lie on this line called x equals y. Okay, so now let's graph this other one and see what we see about it. If we just choose some points, since this is even, or since this is going to wind up even, I'm just going to pick numbers for y where we wind up with an even number. So I can start with 0. So in this case, I'm choosing numbers for y first. 0 plus 8, 2 times something, so that'll be 4. If we go with 2 for y, then we get 10 over here, which means that x needs to equal 5. So we've done it. I've done 2 points. Let's figure out where they meet. So 1, 2, 3, 4, 0, 5, 2. Okay. I have my 2 points. I'm going to make my line. Okay, so there's my line. Once again, just a line. It's nothing more complex than that. So this is the equation 2x equals y plus 8. So that's what they look like. This is a picture, a picture representation of each of these equations, of each of these linear equations. Now, what you do when you solve simultaneous equations is figure out where they meet. Figure out where these 2 lines meet. So you're looking for one solution, the one point on the graph where these 2 lines are going to meet. And you know that 2 lines can only intersect at one point, at most. So, I mean, unless they're the same line, obviously. And it looks like they meet up here at 6, 7, 8, 8, 8. Let's check and be sure that that's true, that we have it right, because that's just based on appearances. Okay, well, we know it's true for x equals y, 8 equals 8. Excellent. Let's see if it's true in here. If we substitute 8 and 8 in for x and y, we will get 16 on this side, because 2 times 8 is 16. And 8 plus 8 will get 16 on that side too. So yes, it's true. That happens to be the point where they meet. Now, by all means, every time you solve simultaneous equations, you can do it like that. You can draw the picture, and where the 2 lines meet is going to be what you're looking for. But as you can imagine, we lazy mathematicians want to find an easier way to do it. Okay, so there are I think of 3 different ways that maybe only 2 different ways that I tend to solve these. Okay. Well, no, 3. I don't have an example of the 3rd kind. Okay, so, but let's start with this one, this first one. The one that we just did, you can make the pictures, figure out where they meet, check that those points are accurate, right? But let's do it an easier way. You now know how to use the property of substitution really well from your work in geometry. And so let's do that here. So we know that x equals y, and we know that 2x equals y plus 8. So let's substitute in. So you take either one, x or y. Let's keep y, I don't know. So instead of writing x here, we'll write a y. So there we know that 2y equals y plus 8. Now it's just a balance, so you've got 2y on one side and a y and an 8 on the other side. Let's take a y off of each side. And you wind up with y equaling 8. Excellent. Y equals 8, so x must be 8. So the point that we're looking for is 8, 8. Now, I think that was easier than doing it on a graph, but feel free, do it whichever way you like. Let's do a few more examples of how these might work. This is another example that's a slightly more difficult of substitution. In this case, you know that y equals 2x. So in this equation, let's go ahead and substitute 2x in for y here. So now we've got 4x minus 2x equals 14. 4x minus 2x gives you 2x's equals 14. X has to equal 7. Okay. Now, if that's the case, we're going to take 7, put it in here. We know that y then has to equal 14. Let's check and be sure it works. We know it works in this top equation. Let's see if it works here. 4 times 7 is, I'll write it out, minus 14. That should give us 14. Well, 4 times 7 is 28. Minus 14, yes, gives you 14. So that's the pair you're looking for. X equals 7, y is 14. You can also write that like that. Okay. Let's talk a little bit about another way that I like to solve these, or a pretty standard way to solve these. Here it's a little more complicated. The substitution up here worked nicely because you knew that x equaled y, or y equals 2x. It was pretty simple. But here it's a little longer, and so we wonder if we can come up with a different way of solving these simultaneously. And it just so happens that there is an easier way to do it, or another way to do it anyway. I can take this second equation, and you know by the subtraction principle or property that you can subtract y from this side and 4 plus x from this side because they're equal. So let's do that. Let's subtract, basically I'm going to subtract this equation from this equation. And I'm going to get 0 on this side, and then because y minus y. And on this side I've got 7x minus an x, that leaves me with 6 x's. 10 minus 4, that leaves me with 6. Okay, so we need to figure out what x needs to equal in this case. So let's begin the process of getting x by itself. So I'm going to take away the 6 that's on that side. I'm going to subtract a 6, and I'm left with negative 6 over here, 6x over here. And then you see that x has to equal negative 1 for this to be true. Okay, so let's put x equals negative 1 in here, and you get that y equals negative 7 plus 10, which equals 3. So we think that the pair that we're looking for, we think that these two equations are going to meet at negative 1, 3. And let's see if it's true. We know that's true up here. Let's check to be sure it's true here. If y is 3, you get 3 equals 4 plus negative 1. And that's true. So this is it. This is the pair you're looking for there. So that's a general idea of how to do it. I can give you a more complex example if you're interested in class on Friday. This one is another one where, this is the last one I'll do. This was number 3 in the algebra review. This one, I think the easiest way is going to be to use substitution again. If you're interested, I will do this one in a different way in class on Friday. But if we just use substitution to solve these, then y equals x minus 2. So we're going to plug that in for y down here. So we've got 3x plus 1, or 3 times the quantity of x plus 1 equals 4 times the quantity of x minus 2. And now you need to know how to use the distributive property. If you need help on that, talk to me in class. I will just show you what it means. 3 times all of this. So I have to triple everything that's in here. So that leaves me with 3x plus 3. Over here I have to quadruple everything that's in here. So I'm left with 4x minus 8. Okay, and then to solve that, I'm going to take 3 x's away from this side and this side. So I'm left with 3 over here and x minus 8 over here. And then I'm going to add 8 to both sides, and I get that x equals 11. If x equals 11, plug that in up here. That means that y must equal 9. Let's check and be sure that works in the second equation to make sure we did it correctly. So we have 3 times 12, so x is 11, equals, 4 times 9. So 3 times 12 is 36. 4 times 9 is 36. So we did it right. And this is the place on the Cartesian plane where they'll meet up. You can either write it like this or like this. And that is all. Adios. See you Friday. Email me if you have any questions about the material otherwise.